Hello everyone, I hope everyone is fine amidst this COVID crisis, and we have already completed few applications on Op-Amp, and today we will learn about adder. It is sometimes also called a summing amplifier. So let me first draw the figure so that it's easier for you all to understand it. First, ground the non-inverting terminal, and in the inverting terminal, this minus, over here, what we'll do is we'll add a few resistances. Okay, so how we going to do that? Suppose we'll take in this format. I'm taking as 4, just consider 4 of them. Apply V1 over here, V2, and this section is V3, this is say V4, and say this one is R1, this is R2, and this R3, R4, okay, and this section is the RF part, this is my output. So this is your basic summing adder or summing amplifier circuit. What I've done is that in the inverting terminal, I have considered 4 different voltages, and which is V1 is being applied to this terminal 2 via R1, V2 is applied via R2, V3 via R3, and V4 via R4 resistance into the same terminal, that is pin number 2, the negative terminal of the op-amp. And this positive terminal, that is the non-inverting terminal, is being grounded. You have the feedback part. Now, since virtual ground exists in op-amp input, the potential at point A, okay, is 0. And the current through the feedback resistance is the sum of the currents from all of these parts. So suppose if I consider I1 current to be flowing from this first resistance R1, then I2 current flowing through this R2 resistance, I3 flowing through this R3, and I4 from R4 resistance. So the current through the feedback part will be actually the sum of the currents, that is I1 and I2 and I3, all of those through the resistors R1, R2, R3 respectively. And as the input impedance of the op-amp is infinite, so we can write like I1 plus I2 plus I3 plus dot 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 is equal to say I0. Okay, I can write like this. So I1 is actually what? V1 by R1. I2 is what? V2 by R2. I3 is V3 by R3, and dot dot dot. I0 is what? The output current via this feedback resistance. So I'll get minus V0 by RF. Okay, I hope it's visible. Okay, so if I apply 2 conditions over here, that is, if I say just note down this figure. Okay, I'll move on to the next page. I'm not going to redraw this part. So if I apply a condition, this is equation number 1, say this is equation number 2. If I apply a condition that R1 is equal to R2 is equal to R3 is equal to say dot 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 Rn, then what happens is this V0 will become minus Rf by R1 into V1 plus V2 plus V3 plus dot 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 Vn. So this is your equation number 3. So what you see over here is that the output is proportional to the sum of the input voltages. So this output is proportional to the sum of the input voltages. Now if I say in addition that if RF and R1 is same, so another condition I'm reviving apart from this condition, that if R1 is equal to RF, then what we get is V0 is equal to summation of Vi over I. I hope you're understanding this part. So the output voltage is equal to the inverted algebraic sum of the input voltages. Okay, I hope this part is clear to you all. Just go through this part, jot down this section, and if you have any queries, please drop in your questions in the chat box or you can write to me. Okay, take care until our next class. Thank you.